Okay, so let's slowly get into our app. So our app will look something like this. We'll have the Chinese word for a certain number, right? This is 10. And we have the pinyin down here, which we can remove or put back. So,
10
okay, I got that right. This is 70 something, 74.
74
Okay, great. Of course, you want to understand the rules, right? How are two-digit numbers constructed. So we'll get into that afterwards. We'll have also the ability to adjust the volume.
91
And we can keep playing this.
Oh, yes.
Okay, and then we have the score. You solved 4 out of 5. You're amazing. Click to start over. And down here we have a random quote that was grabbed off the internet. And we have this cool background image. Okay, great. So this is pretty much the project. And yeah, let's get into it. Okay, so I'm going back to this part of our app. And first of all, let's set a little bit folder structure up. Right, so I'm going to create a new group. Let's call this view. Another group called view model. And another group called model. We might add some more groups later, but that's the general structure. And I want to start with the game model, right? So let's go to the model over here, the model folder, press Command N, and create a Swift file. Okay, Swift file. So I'm going to call this game model. And we're going to create a structure, which we're going to call game model. Okay, that makes sense. Now, I'm going to define a variable called score. I want us to have a max number of turns, which I don't really expect us to change, at least in a given game. So let's let this be a let constant. Next, we'll have the volume, which will be a float and not a double. And that's just for a very specific reason, which we'll see later. Next, we'll have a variable called turns, which is an integer. And I'll add a comment. This is the turns played so far. So at the beginning, this should be set to 0. And we have our answer, which is an integer. And we also have some alternatives, which is also an integer. So this is just the possible solutions, including answer. Okay, so the correct solution is there too. Okay, now we want a variable called game over. Or maybe let's start first of all with game completed. Okay, so the game is completed, or maybe I'll just call it game 1. This is going to be a computed property if the turns is greater or equal to the max turns. Okay, in other words, we made it through the game without getting a negative score, right? A negative score for me means that that's it, you cannot continue with the game. And we can change the rules, right? You don't have to use the rules I'm using. And we also have a variable called game over. So game over can happen in 2 situations. Either the score is negative, or we won the game, or completed the game. It would be better to call this game completed, but just taking game 1 is shorter. So I'm going to go with game 1, and later we can refactor this if we want. Okay, and now we'll have some code related to the score. So we can do func increase score. So score plus equals to 1. Now we can't really do that in a struct, right? We have to explicitly label that this is a mutating function. So it's changing a value within our struct. Okay, next let's have update turn. I like having explicit functions for this, even though we could just do this within our code later. But so func next turn, and obviously I'm going to need I'm going to need mutating, and we have turns, not turn. And this is going to have to be mutating, so it's a mutating function. And I also want to generate a new problem. Okay. So mutating function, generate new problem, which pretty much means create a new answer and also new alternatives. Okay, so I'm going to leave this as to do. Need to implement, but let's do something, okay? So I'm going to set alternatives. So let's start with alternatives equals to say 6, 23, 5, and 10. And the answer will always be the last value of the alternative. So let the last alternative be the answer. Okay, so this is what we have to do. To do, implement this part. What does that mean, implement this part? That means create an array of 4 different random values between 0 and 99, okay? And let's always decide that the last value is the answer. So answer equals to alternatives 3, okay? I could have gone with alternative 0, and actually I think that would have been a better option, a much better option, because maybe in the future we won't want 4 alternatives, maybe we'll want 6 or 8. Okay, so it'll be the last alternative. So I chose the last alternative. And finally, I don't want it to be obvious where the solution is, so shuffle the alternatives so that the solution appears in a different position. So let's say alternatives is equal to alternatives.shuffled. So we're going to mix it up. But the answer is already found. Finally, I want a default game. So static var default game model dot init. And let's just set a bunch of values. So score and max score should be 0. Okay, let's do this slowly. Let's just finish this part here. So the score is going to be 0. Let's say the max turns is 5. The volume I'm going to set to 0.7. It should be a number between 0 and 1. The number of turns so far played is 0 if we're just starting the game. Let's say the answer is 10. And the alternatives will be just what we just wrote a minute ago. Okay? So we pretty much have the game model, except that we need to implement this part. So we need to create some function for generating 4 different random values. So what I'd like you to do is implement that, right? So implement. So let's do homework. For next time, I'm going to solve it next time. So homework or challenge, implement a function, func generate random integers, generate unique random integers, count number of times. We're going to use 4, and this should be between 0 and 99. There is a catch here, of course. Suppose if you want to generate 200 unique numbers between 0 and 99, that's impossible. So this is the first part. And the second part, which I'm actually I prefer, but we'll do both. create an extension of int which has the same functionality. So same with the same functionality as part 1. So you're probably going to need a static function. Okay, great. So let's take a break, try to solve these problems, because it's really great to see, a different solution, and you're probably going to get a different solution than mine, and that's perfect. Okay, great. So have an amazing day, and we'll solve this next time.